I've created a computer model in Excel, and this model simulates two of the very common force platform designs or systems for performance measurement. So these are uniaxial force plates, only measuring forces applied perpendicular to the plate surface. So I've modeled two designs here, one being a single plate here, which is 0.7 of a meter wide and 0.5 of a meter across here. And also within this, two force plates side by side. So if you like, split down the middle here at this zero line here, with one force plate here and one force plate here. For the single force plate, I have modeled it as having individual load cells in each corner, each providing a force signal. So in other words, the single force platform has 4 force signals being measured. For the dual platform model, we have 2 force plates, but each one only has a single summed force signal here. So it only records a single force signal from each of the plates, so 2 force signals in total. I've set up some starting parameters here in terms of the distances between the load cells and the positions of the left and right feet here. And I've started with an arbitrary distance here of 0.5 meters between the feet, but this can be changed however required to simulate that. We've also entered in the weight force of the participants here at 785 newtons. I've placed sliders here so that you can change the actual asymmetry. In other words, the difference between the left and right or front and back application of force here. So we'll start by examining the effect of asymmetries to the left or right, in other words in the mediolateral plane here. So we'll start off with an initial asymmetry of 10%. So the force going through the left foot here is higher than the force going through the right foot, and the actual asymmetry calculation is 10%. What we see is that with this, the dual platform system records a left foot force here of 412 and right force of 373. But the same asymmetry is recorded for the single platform with 4 force signals, exactly the same. And the ratio between the left and right feet is the same, 0.9, because it's a 10% asymmetry. We'll increase the asymmetry to 20% or even 30%. And we see that whether you're using a dual force plate system or a single platform, we get the same measurement in terms of the calculated left and right foot force. And of course the ratio between the left and right feet. We also get the same displacement of the center of pressure here of 7.5 centimeters. So we'll introduce even greater levels of asymmetry. You can see the values here, 30%, 40%, 50%, etc. And we see that the asymmetry as measured between a single force platform and a dual platform are identical, and this is to be expected. Similarly, the calculated forces under the left and right feet are identical if the distances between the feet are known for either system. So now we'll introduce some asymmetry in the front to back plane, so anterior posterior. So we'll shift the weight forward here, and we'll take it forward here by 40%. Now, due to the force signals received only having 2 force signals from the dual plate system, it's unable to resolve any shift in weight force in the anterior posterior plane. So the asymmetry front to back remains at 0 for the dual plate system, whereas the single plate system can actually register and measure the forward shift of 40% in weight force. Then, as we change further left to right, we can see that the two track exactly identical in terms of the mediolateral asymmetry and shift in weight force, but only the single plate system with 4-force signals can resolve weight shift in the anterior-posterior plane. Now this is important because assessment of the center of pressure and the shift in the center of pressure is very important. It's crucial for the measurement of balance and stability. And so this is a disadvantage of the dual platform systems, is that they're unable to resolve any shifts in force in any plane other than the left to right. And they can only determine the shift in the center of pressure to the left or right if the distance between the 2 feet is known. The distance between the 2 feet, whilst we've entered it here at 0.5, it is not actually required to determine the center of pressure for a single plate system. The center of pressure for a single plate system can be measured simply using the 4 load cell signals. So this is reflected here in the actual center of pressure location in the anterior-posterior plane. We can see it's 0.1 of a meter here, but the dual plate system is unable to measure this, so it records as 0. And then also with this data, with the single force plate system, we can actually determine the displacement of the center of pressure relative to the origin at 0.18 of a meter. So that is the distance from the midpoint of the platform to the center of pressure. So in summary, single platforms and dual platform systems have their advantages and disadvantages. Certainly a single platform with 4 force signals can accurately track the center of pressure with weight shifts in both the anterior-posterior and mediolateral planes. And this, of course, is excellent for determining asymmetries between the left and right as well. Dual platform systems cannot resolve any shift in force in the anterior-posterior plane. They can only measure the left versus right forces applied. And they cannot actually track the center of pressure here unless the distance between the 2 feet is known. Conversely, a single force platform cannot determine the force being applied by the left and right foot individually unless the distance between the 2 feet is known. So in deciding which force platform system is preferable for your particular needs, it really comes down to priorities. Are you only interested in determining the summed force on the left side and the right side? Or is it also important to be able to actually track the center of pressure? Both systems, as we have seen, are able to determine asymmetry in the left and right directions, in other words, the mediolateral plane. But only the single platform with 4 force signals can resolve shifts in force in the anterior-posterior plane.